Good morning, Cappuccino. This is second week of home learning and schooling. It's Thursday, March 26th. Here's a reminder, this was the last warm-up we did. This was on Tuesday. I did not post a warm-up on Wednesday yesterday because I was super busy trying to figure out a bunch of stuff. So here's today's warm-up. Okay, so given this and that the mean of this is 4.8, find the value of P. All right, so go look at your notes. What the heck does this all mean? What does this mean? Huh, mean? What does, get it? Huh, funny. Okay, so use your formulas. No context here to help you figure it out. You just got to use the formulas, all right? 10 points extra credit for the first person who gets it in. 5 points extra credit for as many people as I feel like giving 5 points to after that. By the way, the winners of the previous one were, no, I'm not even sure. I think it was Jaden was number one, Jocelyn and Camilla got points for this one. So this one was a toughie. So let's have a look at this one right now. Solve for the probability P that a glass is broken. So we know that the expected value is 3. So expected value, the E of X, the expected value is 3. And we know that the formula for E of X is N times P, N times P. And we know that the number of trials is going to be 8. There's 8 glasses in each box. So we're basically looking at, if we have 8 glasses, what's the probability that it will be broken, a glass will be broken. So we have 3 is equal to 8 times P. What's the probability? Divide by 8. And you get that P is equal to 3/8. Okay, so the probability that a glass is broken is going to be 3 out of 8. Okay, the average number of broken glasses out of 8 is 3, so the probability is 3 out of 8. Kind of makes sense. Now for the hard part. What is the probability that at most half of the glasses will be broken? Okay, so what is that? Probability that at most half. Well, what's half of 8? That would be 4. So what's the probability that at most 4 will be broken? So that means I want to know what's the probability that 0, 1, 2, 3, and 4 are going to be broken. So I want X to be less than or equal to 4. Okay, because at most I want to have half of them broken. What's the probability of that? But notice, broken if at least one is broken. This is a given problem. This is a conditional probability that we got going on here. Let me get rid of this pen. It's kind of lousy. So this is going to be a conditional probability. So I need to find the probability of the intersection of these two things. So the intersection of X being less than or equal to 4 and broken if at least 1 is broken. So X is greater than or equal to 1. I need to find the intersection of that and divide it by the probability of at least 1 being broken, because what I'm asking for is conditional probability. What is the probability that I will have less than or equal to 4 given that only more than one or more is broken? So I can set it up like this. It's conditional probability. And so therefore, I need to find the intersection of these two things happening and divide it by the probability of 1 or more being broken. So to get the intersection, the way I did that is I kind of thought about it as a Venn diagram. So to get this one, I was just thinking about what are all the instances that they have in common. So if this is the probability of X being less than or equal to 4, and this is the probability of X being greater than or equal to 1, what do they have in common? Okay, so 4. Do they have 4 in common? Is 4 part of this one and part of this one? Yeah, so they have 4 in common. What does this have? This is 0, 1, 2, 3, and 4, right? So they have 4 in common. What about 3? Is 3 greater than or equal to 1? Yep, they have 3 in common. What about 2? Yep, they have 2 in common. They have 1 in common. What about 0? 0 broken glasses is less than or equal to 4, but is that 0 greater than or equal to 1? No. So 0 is not included in the overlap. And then likewise, what else isn't included? 5 is not included in the overlap, 6, 7, or 8. Those are not included. So the overlap are going to be these four things. So I want the probability of 4, 3, 2, and 1 is going to be in my numerator. And then the probability of x being greater than or equal to 1 is going to be in the denominator. So I kind of did this the long way because I don't trust my calculator skills. So what I did is I said, okay, in the numerator, I want the probability of x being equal to 4 plus the probability of x being equal to 3 plus the probability of x being equal to 2 plus the probability of x being equal to 1. That's the overlap, and I'm going to divide it by the probability that x is greater than or equal to 1. Now, I'm actually going to use the shortcut on the calculator for this one. But remember, the cumulative probability only works with less than symbols. So I need to rewrite this as a less than. So it's going to be 1 minus, now what's the opposite of this? The opposite of this would be the probability of x is less than 1, but not equal to. Okay, so it can't be equal to, and when I put it into the calculator, it has to be like this, less than or equal to, but it can't be 1 because 1, I want 1. 1 is part of my answer. So this is going to be 0. What's the probability that none of the glasses are broken? So 1 minus the probability that none of the glasses are 0. That'll give me the probability that at least one of the glasses is broken. So this is what I'm going to do on my calculator. Okay, so then I would grab my calculator, and hopefully this is what I did because I did this 2 days ago and my notes are a little messy, but let's see. I think this is what I did. So I did second, vars, and then I went to A, and my trials were 8. My probability is 3/8. Look, I already had it in there. Oh, I did the denominator first, but never mind. I'm going to do this one. X equals 4, and I got my answer. There it is. Okay, so this one's going to be 0.211. And then I did it again. Second vars, the option A, and then I have 8 3/8. And now I want x value to be 3, and I get 0.282. By the way, I'm not going to use these numbers I'm writing down. I'm actually going to use them in my calculator. So yeah, for those of you who are like more clever than me, you're like, oh my gosh, Ms. Castro, there is such a faster way of doing this. Fine, do it the faster way. Awesome for you. I'm doing it the slow way because that's who I am. I'm slow. All right, so this one is 0.235, and the next one, I want 1. Get that answer. 0.112. Okay, so if I add those all together, that's going to be my numerator. So let's go ahead and add that. So I'm taking that one plus, oops, that one plus that one plus that one equals, all right, so I'm going to keep that in my calculator. I'm also going to write it down so I remember what's what, 0.839, okay, but I'm going to keep it in my calculator. Now on the bottom, I'm going to have 1 minus the probability that x is less than or equal to 0, which for all practical purposes is the same thing as x is equal to 0, right, because there's nothing less than 0 in my probability. I can't have less than 0 broken glasses. I can't have -1 broken glasses. So this is actually the same as this. So I can actually get this number by just using the, I don't need to use the cumulative probability function. So I can just do it again with the option A. So 8 trials, 3/8, 0. I get that. And so remember though, this is 1 minus that. So I'm going to minus that from 1. And that gets me, don't worry about the negative, I'm going to discard the negative, 0.977. Okay, so, or I could do this. I could do 1 minus and then go back up, and if that makes you feel better. Okay, there it is with the positive value. So that's my denominator. My numerator was all the ones that I added together, which is up here. So now I'm going to go and take that numerator. There it is. Okay, that's the overlap of the two choices, and I'm going to divide that by the, where am I? There we are. Sorry, I was hitting the wrong arrow. Divided by the probability that that at least one is broken. And I get, good, I got the right answer. Because it's been a couple days since I did this. All right, and so the answer was, in three significant figures, 0.859. There it is. Whew, that was a tough one. Today's problem is way easier, so good luck on it. I did want to mention something about the adulting. I think everybody needs to do the adulting math space assignments, especially since yesterday I didn't put up any other type of assignment. I put up the those self-guided, what are they called, diagnostics for people who want to do them, but you don't have to. If you want to know where your strengths and weaknesses lie, go ahead and do the diagnostics that I put up on MathSpace. But let's go ahead and have everybody do the adulting MathSpace assignment. So yesterday, the thing that most people seem to be confused about, what is a debit and what is a credit? So yesterday's adulting problems were basically about balancing a checkbook and being able to make a budget. So balancing your checkbook, being able to look at your bank account and know what things mean is really important. So a debit is money coming out of your account, money out of your account. And credit is money going into your account, into your account. And I think people were confused by the word credit, because oftentimes people think of credit as a credit card, and that's where you're borrowing money. Okay, so that has a different meaning, right? If it's a credit card, you're actually going into debt. You're actually borrowing money if you're using a credit card temporarily. But in the context of the problems in yesterday's adulting number 1 math space assignment, they were talking about basically a bank account. So in a bank account, so this is for a bank account. So in a bank account, debits is money that's taken out of your account, and credits is money going into your account. So you like credits, you do not like debits. Okay, debit is money going bye-bye, credit is money coming into your account. So if you have an interest earning savings account, you will get credits like every month from your bank giving you the interest on the money that was in your account. So whenever you have an option of earning interest or not earning interest, you want to earn interest, because that means the bank is going to put money into your account. You're going to get extra credits into your account. Okay, debits, like you have a debit card from a bank. So you go to the ATM and you put in your debit card so you can take money out of your account. So debit means money out, credit means money in. All right, on your mark, get set, math.